Have you ever stopped to think about how something as basic as steering can be completely reinvented? Well, that's exactly what we're talking about today, with a piece of tech that did just that for airplanes, fly-by-wire. It's this invisible system that's at the heart of the safety and efficiency of pretty much every flight you take. And to really get what a big deal it is, we first have to get our heads around the massive problem it was built to solve.
I mean, really think about that for a second. The scale is just staggering. You're trying to make these tiny, precise adjustments to something that weighs as much as 200 cars, all while it's blasting through the air. The forces at play are just immense, and your margin for error is basically zero. So how on earth did we manage to do that?
For the longest time, the answer was just brute force. The pilot's controls in the cockpit were physically connected to the parts that steer the plane, the ailerons, the rudder, the elevators, using this enormous complicated network of metal. It was basically a mechanical nervous system that ran all the way from the cockpit to the wings and tail.
But, as planes got bigger and faster and way more complex, this whole direct mechanical approach, well, it started to really show its limits. It was literally like trying to fly a giant on a bunch of strings.
And here's where the problems just start to pile on top of each other. The systems themselves were insanely heavy, which is terrible for fuel efficiency. Trying to route all those cables and pipes through the aircraft was a total design nightmare. And for safety, you needed backups, which, you guessed it, added even more weight. But the biggest thing, these systems were dumb. They couldn't adapt to anything. And the pilot literally had to muscle the plane through every little change in the air.
So, the solution was to cut the strings completely. It was time to move from a system of pure physical force to one of electronic intelligence. This was the big shift from muscle to the microchip.
And that brings us to the core idea right here. Fly-by-wire does exactly what it sounds like. Instead of yanking on a cable, the pilot's control stick now sends an electronic signal, through a wire, to a flight computer. That computer then figures out the pilot's intention and tells the hydraulic actuators exactly how to move the control surfaces with perfect precision. What makes this so incredibly powerful is that it's a closed-loop system. The easiest way to think about it is like a really good video game controller. The pilot's input is the reference. That's what they want the plane to do. The computer then moves a control surface, and sensors immediately measure what the plane is actually doing. That's the output. And the computer is constantly comparing the two, making thousands of tiny adjustments every second until the plane's action perfectly matches the pilot's command.
Now, this tech didn't just pop up overnight. It actually started way back in 1958 with the Canadian Avro Aero proving the basic idea could work. But the real game changer came in '72 when NASA flew an F-8 Crusader using a purely digital system. And get this, it was powered by a computer from the Apollo moon missions. But it was 1988 when fly-by-wire finally hit the big time, with the Airbus A320 bringing it to commercial airlines everywhere.
And these two planes, man, they just show you what a long journey this was. You've got the Avro Aero on the left, which looks like something out of science fiction. It was so ahead of its time. And then the NASA F-8 on the right, it doesn't look that special, but inside, it was running the software that would literally define the future of flight, years before most people even had a computer in their house.
So all of that hard work, all that innovation, it led to a massive payoff. I mean, replacing tons of heavy metal with lightweight wires and smart computers completely changed how we design airplanes and how safe they are. The benefits were just huge. First off, the weight savings are dramatic, and that directly means better fuel efficiency. But the smart part is where things get really cool. The computers can actually protect the plane from the pilot making a mistake. It's called flight envelope protection. The computer knows the absolute limits of the aircraft and will simply not allow a pilot to make a command that would put it into a stall or a spin. The system is basically saying, nope, not going to let you do that. This makes flying so much safer and takes a huge workload off the pilots. And you can see the end result right here. This is an Airbus A320 cockpit. Instead of that big, bulky steering yoke connected to a bunch of pulleys and cables, the pilot just has this simple little side stick. The whole interface is cleaner, it's more digital, and it lets the pilot focus on managing the flight because the computer is taking care of all the tiny details of actually flying the plane. Now, what's really fascinating is that not everyone decided to use this technology in the same way. This slide gets into the two competing philosophies from the giants, Airbus and Boeing. Airbus basically decided that the computer should have the final say to protect the aircraft. Its system will not let a pilot go past the safe limits, period. Boeing, on the other hand, took the view that the pilot must always have the ultimate authority, and they can override the computer's protections if they believe it's absolutely necessary.
It's this incredible debate about the true role of the human versus the machine in the cockpit.
Of course, anytime you decide to hand over control to a computer, the very first question on everyone's mind is, what happens if it breaks?
It's the ultimate fear, right? We've all had a computer freeze up or give us the blue screen of death. What in the world happens when that computer is flying an airplane with hundreds of people on board? Well, you can bet the engineers thought about that from day one.
The answer on many modern jets is this number, 4. And it stands for one of the most critical concepts in all of modern engineering, redundancy. See, you don't just have one flight computer. You have 3, or more often, 4 of them, all running at the same time doing the exact same calculations. They are constantly cross-checking each other, and if one computer suddenly starts giving a weird answer, the others just vote it out of the group and ignore it. On top of that, they're all connected to the control surfaces through their own separate independent wiring. And even after all that, most planes still have a basic mechanical backup system as an absolute final failsafe. The layers of safety are just immense.
So if flying by wire is the standard today, what comes next? Well, the revolution isn't over, it's just getting started.
Fly-by-wire is now the proven, established gold standard. It has made flying more efficient and safer than we ever could have imagined. But, engineers are never satisfied. They're already working on the next big steps.
First up is something called fly-by-light, or fly-by-optics. This replaces all those electrical wires with fiber optic cables. Now, why would you do that? Well, fiber optics are even lighter, but more importantly, they are completely immune to electromagnetic interference, which makes the whole system even more reliable. And it's not science fiction. This aircraft right here, the Kawasaki P1, is already using it.
And if we look even further down the road, the ultimate goal is to just get rid of the physical connection entirely, fly by wireless. Imagine that. It would eliminate thousands of feet of wiring, saving a massive amount of weight and making it so much simpler to build and maintain an aircraft.
Which really brings us back to this one final thought. From simple wires to light, and maybe someday to wireless signals, we are steadily giving our computers more and more authority. They're not just tools anymore, they're becoming true co-pilots. And that central question, the one that Airbus and Boeing are still debating, remains. What's the perfect balance between human experience and machine precision to make sure our skies are the safest they can possibly be?